Hey Fast Track, so our first virtual lesson is going to be the introduction to trigonometry. So let's start by defining trigonometry. Trigonometry is the relationship between the sides and the angles of a right triangle. Now let's identify our 6 trig functions. The very first one is sine, and it is abbreviated sin. The second trig function is cosine, abbreviated cos. The third one is tangent, abbreviated tan. These next 3 trig functions are what I call the reciprocals. You'll see why in a minute. The fourth one is cosecant, abbreviated CSC. The fifth one is secant, abbreviated SEC. And the final one is cotangent, abbreviated COT. Now let's apply that to this following triangle. So given this triangle, let's set up the following ratio. So sine of theta, cosine theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. So in order for you to do that, you have to know the following acronym. You have to know what SO, CA, TOA means. So here's what it means. So the S in SO is for sine, and the sine is the opposite over the H is for hypotenuse. So the sine of theta is the opposite over the hypotenuse. The C stands for cosine. The A stands for adjacent over the H is for hypotenuse. So the cosine is adjacent over hypotenuse. TOA stands for, well, first the T stands for tangent. The O stands for the opposite over the A, which is the adjacent. So keep in mind that opposite, adjacent, and hypotenuse, what I mean by that is the sides of the triangle. So let's look at that even further. So let's look at the triangle on the left. Notice that the angle that we're looking at is this theta here. So that symbol just represents angle measurement, and that theta is denoted by that symbol there. So let's label our sides. So if this is the angle that we're looking at, the side right across from it is the opposite. So our opposite side is 2. Now the side right next to it is called the adjacent. So adjacent just means the side right next to it. And of course, the last side is the hypotenuse. The hypotenuse is the side right across from the 90 degree angle. Now that you know what SOHCAHTOA means, let's set up our 6 ratios. So again, the first one is sine of theta, and you told me that sine represents opposite over hypotenuse, and if you plug that in, the opposite side measures 2, and the hypotenuse measures 3. So the sine of theta is 2 over 3. That's the ratio. Now, cosine. Cosine is the adjacent over hypotenuse. Now let's look at our triangle and label. The adjacent side is 1 and the hypotenuse is 3. So our ratio is 1 over 3. Our third one is tangent of theta. And from TOA, you know that the tangent is opposite over adjacent. So now looking at the triangle, the opposite side measures 2. The adjacent measures 1, and if you reduce that, you get 2. So now let's do the remaining 3 trig functions. So remember what I said about these last 3. They are the reciprocal of these original 3. So here's how I remember that. So the last one is cotangent, and of course, cotangent and tangent sound very similar. So the cotangent of theta is the reciprocal of tangent. In other words, the adjacent over the opposite. Secant is the reciprocal of cosine, leaving that to be hypotenuse over adjacent. And the last one is cosecant. That is the reciprocal of sine. So cosecant of theta is hypotenuse over opposite. And again, I'm just flipping these right here, the reciprocal. Now, here's an easy way to remember that. Obviously, tangent and cotangent both have tangent in them, so those are easy to remember. But the remaining 2 are a little bit harder to remember, but here's how I remember it. Sine starts with an S, so I just pair that up with the C, and here's why. Cosine starts with a C, just pair it up with the S. So if you find that helpful, remember that. If not, find your own way. So again, cosine of theta will be the opposite. That is not correct. The cosecant of theta is hypotenuse over opposite. Now looking back at the triangle, hypotenuse is 3 and the opposite is 2. So cosecant of theta is 3 over 2. And of course, it's the reciprocal of sine, as you can see. The secant of theta is hypotenuse over adjacent. Looking at the triangle, the hypotenuse is 3 and the adjacent is 1. 3 over 1 reduces to 3. And of course, the secant is the reciprocal of cosine, and that's correct. The last one is cotangent. Cotangent is adjacent over opposite. And looking at our triangle, the adjacent side is 1, the opposite is 2. And as you can see, the cotangent of theta is the reciprocal of tangent. So go ahead and try this on your own. So pause the video, work it out in your notebook. Okay, so the first thing I would do is label my triangle. So notice that the theta, the angle that we're looking at, is right here. So let's label our sides. The side right across from it is your opposite. And notice that our opposite side measurement is missing. So we're going to have to find that in a minute. The side right next to it is called the adjacent. So the 12 is the adjacent. And of course, the side across the 90-degree angle, that's your hypotenuse. So before we start finding our ratios, let's find the missing side, our opposite side. So notice that you have a right triangle. And if you have a right triangle, you can apply the Pythagorean theorem. So again, that's from middle school. So a squared plus b squared equals c squared. Remember, c is always your hypotenuse. So we have a squared plus 12 squared equals c squared, which is 13 squared. And if you simplify that, you get the following. Solve for a. So minus 144 on both sides. A squared equals 25. To get the a by itself, you take the square root of both sides. So a equals 5. So our missing leg is 5 units long. So now let's find our ratios. So again, you cannot find the ratios unless you know so, ka, toa. And again, so represents sine of theta, and sine is the opposite over the hypotenuse. The CAH represents cosine of theta, and that's the adjacent over the hypotenuse. And the last one, TOA, that represents tangent of theta, which is the opposite over the adjacent. So now that we have our SOHCAHTOA and our triangle labeled, let's do our ratios. So the first one is sine. So remember, sine is opposite over hypotenuse. So looking at our triangle, the opposite side is 5. The hypotenuse is 13. So the sine of theta is 5 over 13. The next trig function is cosine of theta. Cosine of theta is adjacent over hypotenuse. Now let's look at the triangle. The adjacent side measured 12 units and the hypotenuse measures 13. So the cosine of theta is 12 over 13. Now tangent of theta. Tangent is opposite over adjacent. And looking at the triangle, the opposite is 5 and the adjacent is 12. Now, if you know the reciprocals of these three, you should just be able to look at these and get the answer. But let's do it the long way for the purpose of you practicing. Now, secant is the reciprocal of cosine. So since cosine is adjacent over hypotenuse, you flip that and you get hypotenuse over adjacent. And look at the triangle. Hypotenuse is 13, adjacent is 12, and the secant of theta is 13 over 12. And of course, these two are the reciprocal, so you know you are correct. Cosecant. Cosecant is the reciprocal of sine. Sine is opposite over hypotenuse. So if you flip that, you get hypotenuse over opposite. Now by looking at the triangle, you get 13 over 5. So the cosecant of theta is 13 over 5. And of course, sine and cosecant are reciprocals. So now that you see the trick, cotangent will be the reciprocal of this, which is 12 over 5. Now let's apply all of that to the following problem. So use trig to help you find the missing sides or the angles for the right triangle. So for example 1, we are trying to find theta. So what I mean by that is we are trying to find the measurement of this angle. So the very first thing that you do is label the given. So you're given this triangle. If you're using this theta, let's label our given sides. So the side right across from that angle is called the opposite. So we're given our opposite side, and we're also given the side right next to that angle, which is the adjacent. So now that you know the given, you're given the opposite and the adjacent, we have to go back to SOHCAHTOA to see which acronym helps us solve this problem. Now, we said that we are given the opposite and the adjacent. Therefore, this problem yields us using tangent. So tangent of theta equals the opposite, which is 5 in this problem, over the adjacent, which is 4. So remember, we're trying to find theta, the angle measurement. So to get the theta by itself, you have to get rid of this tangent. So this is something new for you guys. To get rid of that tangent, you do what's called the inverse tangent. So that's tangent to the -1 power. That's called tangent inverse. So if you do the inverse tangent of both sides, you get the following. Tangent and inverse tangent cancel out, leaving you with theta. All you have to do now is put this in the calculator and you are done. So since you don't have a calculator at home, I need you to use Desmos.com or download the app. So here's how you do it. Here's the app. So I am typing in tangent inverse of 5 over 4 on the calculator. So click on the functions key. We said tangent inverse of 5 over 4. Oh, that's not right. Tangent inverse of 5 divided by 4. So we got 0.89. And I know that's not correct because our calculator is not in the correct mode. So before you do any of your classwork, make sure your calculator is in degrees. So to get that, you click on, let me find it. You click on this symbol here, the little key tool, and you have to hit degrees. So notice that once I changed it to degrees, the answer changed over here. So tangent inverse of 5 over 4 is 51.34. So theta equals 51.34 degrees. So we just found the measurement of angle theta using trigonometry. So go ahead and try the following problem. So find theta. Once you've tried it, come back to the video and see if you got the answer correct. Okay, so the very first step is to label your triangle. If this is your theta, let's label the given. So they give you the side right across from it, that is your opposite. And the side right across the 90-degree angle is your hypotenuse. So we were given the opposite and the hypotenuse. So let's go to our friend SOHCAHTOA. And again, you were given opposite and hypotenuse. So in this case, we'll be using the sine. So the sine of theta is equal to the opposite, which is 2, over the hypotenuse, which is 5. So we're not done yet. The goal is to get the theta by itself. They want the angle measurement. So sine of theta equals 2 over 5. To get the theta by itself, you have to do sine inverse on both sides. Now these two cancel out. So theta equals inverse sine of 2 over 5. So let's go to our Desmos calculator and type it in. So go to functions, inverse sine. I'm typing in the wrong thing. Inverse sine of, what was that, 4 over 5? 2 over 5. So inverse sine of 2 divided by 5. And the degrees are 23.58. So theta equals 23.58. So again, the angle measurement for this angle is 23.58. Okay, so for example 2, let's solve for the x value and then we will solve the triangle. So let's focus on this part first. Let's solve for the value of x. So given the triangle, let's label the given. So again, the measurement of this angle is 35. Let's label our two given sides. The side right across from the angle is always the opposite, and the side right across the 90-degree angle is the hypotenuse. So we were given opposite and hypotenuse. So let's write down SOHCAHTOA. Again, we were given the opposite and the hypotenuse, therefore we're going to use sine again on this problem. So the sine of, this time we know the angle measurement. The angle is 35 degrees. So instead of theta, you put 35. So sine of 35 equals opposite, which is 6, over the hypotenuse, which is x. So keep in mind that in this problem, we're trying to solve for x, the side measurement. So to get the x by itself, you just do the following. Multiply both sides by x. X times sine of 35 equals 6. Let's do opposite operations. It is being multiplied by sine of 35, so you divide by sine of 35. So x equals 6 divided by sine of 35. So again, let's go to the Desmos calculator and type it in. So 6 divided by sine of how much? 35. So the side measurement is 10.46 units. So again, you can use trig or SOHCAHTOA to find angle measurements and side measurements. Now let's answer the second part of the question, which is to solve the triangle. By that I mean find all missing sides and all missing angles. So keep in mind that, let me redraw the triangle. We know that this angle is 35 degrees, so we know that this opposite side is 6 units. And now we know that the hypotenuse is 10.46. So if we label this side, that's the adjacent side. So let's find the measurement of the adjacent. And of course, since it's a right triangle, you can use Pythagorean theorem. So I'm going to erase all of this to have space to solve for the adjacent side. A squared plus b squared equals c squared. So a squared will be 6 squared plus b squared. And again, c is always your hypotenuse. So 10.46 squared. So 6 squared is 36 plus b squared equals 10.46 squared. So back to the calculator. 10.46 squared, that's 109.4. Subtract 36 on both sides. So So 109.4 minus 36 is 73.4. And the last step, to get the b by itself, you take the square root of both sides. So b equals the square root of 73.4. And the side measurement is 8.6 if we round. So our adjacent side is 8.6. So we are almost done with the second part of the problem, which is solve the triangle. So remember, that means find all missing sides, which we have. Now we have to find the missing angle. So remember, this angle is 35 degrees. This one you already know is 90 degrees. So we have to find this missing angle. Let's call that angle A. So we're trying to find the measurement of angle A. So if you remember from geometry, the measurement of the three angles inside a triangle add up to 180. So 90 plus 35 plus the measure of angle A should give us 180. So let's add these two up and subtract that from 180. So this gives us 125. And if you subtract that from 180, you get 180 minus 125. It's 55. So the measure of our missing angle is 55 degrees. So that's what I mean by solve the triangle. So pause the video and try the following problem. So let's first solve for x. To solve for x, let's label our triangle. Here is the given angle, so the side right across from it is your opposite. And the angle, or the side across from the 90-degree angle, is your hypotenuse. So we were giving the opposite and the hypotenuse. So if I write my acronym down, again, we were giving the opposite and hypotenuse. So again, for the third time, we'll be using sine. So the sine of theta, but we know the angle measurement, which is 25, is equal to opposite, which is x, divided by hypotenuse, which is 10. So let's solve for x to finish off the first part of the problem. Times 10 on both sides. So x is equal to 10 times the sine of 25. So again, let's go to the Desmos calculator and type that in. So 10 times the sine of 25 is 4.2. So we just found our opposite side. So let me redraw the triangle. This angle is 25 degrees. Our opposite side we just found is 4.2. And our hypotenuse is 10. So now let's solve the triangle. And again, by that I mean find all missing sides, all missing angles. This time let's call this angle B. So let's find the measure of angle B first. So again, the measurement of the addition of all three angles in a triangle add up to 180. So 90 plus 25 plus the measure of angle B equals 180. Add these two up, you get 115. Subtract 115 from both sides. You get 65. So the measure of this angle is 65 degrees. The only thing that we're missing is the side at the bottom. So it's a right triangle, so again, Pythagorean theorem. .2 squared is 17.64. Subtract 17.64 on both sides. Is 82.6. I didn't do that right. It's 100 minus 16.64. 100 minus 17.64. So it's 82.36. Last step, take the square root. So the square root of 82.36 is 9.08. Okay, so this is the end of your first virtual lesson. Make sure you like and subscribe to Palomo TV.